Hi everyone, welcome back to my LeetCode series. In today's episode we're tackling LeetCode problem number 21, merge two sorted lists. This is a classic linked list problem that appears frequently in interviews. Whether you are new to linked list or you want to refresh your skills, this video is for you, so let's dive in. So the problem says the following: merge two sorted linked lists into a single sorted linked list. The new list should be made by splicing together the nodes of the first two lists. For example, if we have these two sorted lists, the first one being 1, 2, and 4, and the second one 1, 3, and 4, our output should be 1, 1, 2, 3, 4, and 4. The challenge is to merge two sorted lists efficiently while preserving the sorted order. Let's see how to solve it. Here's how we'll approach this problem step by step. First, let's start with a dummy node as the head of our merged list. In this case, let's give it a value of 0. Then, we'll iterate through both lists until one of them is fully traversed. At each step, we'll compare the current values of the nodes from both lists. If the value from list 1 is less than the value from list 2, we'll add the node from list 1 to the final list. Otherwise, we'll add the node from list 2. This way, we build the merged list while maintaining the correct order. In this example, the current node value of list 1 is not less than the current node value of list 2. Therefore, we append the node from list 2 to our final list. Now, 1 is less than 3, so we append 1 to the final list. 2 is also less than 3, so we append it. 3 is less than 4, and then we append the node with value of 4 from list 2 to the final result, meaning that one of the lists is fully traversed. And now that we only have one list, we simply attach the remaining nodes from that list into the final list. Finally, we have to return our output. However, we cannot do it from the dummy node that we created. We have to return it from the node that is after it. In this case, it's the node with value 1. Now that we have a plan, let's code. So the first thing we have to do is create our dummy node. We're going to use list node for this. And we're also creating a head that will point to this dummy node, so we can keep track of the starting point of our final list. So now we're going to create a while loop to iterate through both lists. So we write while list 1 and list 2. This means while we're visiting an existing node in any of these lists, we continue with our loop. And we're going to compare the current node value from list 1 with the current node value from list 2. And if this one is smaller than the one from list 2, we're going to add it to our final list. And we can do that by saying that the next value after the dummy node we created is going to be the value from list 1. Now we have to update the current value of our final list, and we do it by saying that the current value, which is dummy, is going to be the value that we just appended, which would be dummy.next. And we also update the current value of list 1 following a similar approach. We say that the new value is going to be list1.next. And for the else part of our if statement, if the current node value of list 1 is not less than the one of list 2, we're going to append the current node of list 2 to our final list. So we follow the same steps as before, with the only difference being that instead of updating list 1, we're going to update the current node value of list 2. Once we exit the loop, one of the lists might still have some nodes left. We attach the remaining nodes to the merged list by saying that if the list 1 is the one that contains the remaining nodes, we attach them to dummy.next. If not, we're going to attach the remaining nodes of list 2. The final step is returning head.next, because the dummy node that we created at the beginning was just a placeholder. So we return the node after it, which is the actual head of our merge list. Now we just have to run our code. And now we submit it. And we can see that we have a runtime of 0 milliseconds. Let's analyze the efficiency of our solution. In terms of time complexity, we have a complexity of O of n plus m, where n and m are the lengths of list 1 and list 2, as we traverse each list once. And we have a space complexity of O of 1, as the nodes from list 1 and list 2 are reused and simply connected to the dummy node. And that's how we solve LeetCode problem number 21. If you found this video helpful, don't forget to like and subscribe. Thanks for watching, and I'll see you in the next one.